Okay, so this is a setup that I'm using for now. I've been mainly testing these meters here. Okay, the one on the left, it's set on the 1 amp scale, so it's reading about say 130 milliamps. The one on the right, it's on the 10 milliamp scale, and it's reading about 1.3, I guess. So it's roughly off by times 10 by looks of it, roughly. What I've noticed. Okay, so here's the waveform. Again, we're on times 10 on the probe. So I guess it would be easier just to go up to 100. And we get 100, 200, say about 250 volts on the receiver coil. Of course, this is at a low voltage. I just have it idling here right now. Okay, so if I raise the voltage, I guess what the main thing is I want to show is right now the load on L2 is lit and the receiver coil is lit, but as I turn up the voltage, you can see both meters are going up. So okay, now I'm roughly at 20 volts, and so that's 240, say almost, we'll say 250, and that's 2.2, 2.3, say, milliamps. And of course the voltages are higher on the oscilloscope. So now we're looking at, if that's a 100 volt scale, we're at 1, 2, 3, 4, 450 volts roughly. And that's on the output coil. The input coil's still on the 20, so it's obviously smaller, but they're running roughly about the same. Now, changing the frequency, now if you notice over here, changing the frequency, if I so that's 30 where I was at, that's 40, so it drops down on the amperage on the load, but not as much on the receiver coil. Then if I go to 50, it drops down quite a bit on the load, and still not very much. I don't know if you can see that on the receiver coil. So but obviously we have lost voltage, 1, 2, less than 300 volts. So without putting out as much amperage, I guess, on the load, we're obviously not getting the voltage, but it's still drawing the same amperage roughly. So obviously the power rating's gone down. Now the light doesn't change much because it's pretty well a constant resistive load, but I would almost think that changing the voltage would obviously change the power. So anyhow, these are just some tests that I've been running, and there's another test here too. If I go up higher, okay, now I'm up at 60 kilohertz. It does drop the receiver, and the load does drop. Okay, if I go down or up another one, well, let's just go, there we go. Okay, now we're up to 80 kilohertz. Now that bump that was there, it's gone. Now if you look, the voltage has increased quite a bit. I'll do it again. Okay, so there's 60, there's 70, there's 80. Now you can see the voltage increased quite a bit. Now if you look here, the current is actually still down on the load, but yet if you look at the receiver, it's up. Now if I go after that, if I go down, I don't know if you'd see that, but let's see here. Okay, well, it's going up slightly on the receiver coil. But okay, it's going up about 10 milliamps on the load, and it's going up just a little bit on the receiver coil. Now let's see what it does here. So there's 80, there's 70, so it's going up quite a bit. But then when you go to 60, now obviously I could tune that in a little better, but I'm going up 10 kilohertz, which is quite a bit. Oop. I'm going up 10 kilohertz, which is quite a bit. There's a lot of tuning in between that to fine tune it, but I just found as soon as you get that bump out, and I guess with that frequency it's in with the other spike, it seems to be more productive. Again, like I say, there's the measurements. It's well below 200 milliamps, but yet it's well above the 2.2 or whatever it was there. Now we're not talking a whole lot of current at the moment, but it's something that I'm exploring. Cheers.